This is Barnard's star. Barnard's star is a red dwarf about 6 light-years away from the Earth in the constellation of Ophiuchus. It is the fourth nearest known individual star to the Sun after the 3 stars of the Alpha Centauri star system and the closest star in the northern celestial hemisphere. It is named after the American astronomer Edward Emerson Barnard, who discovered it in 1916. Barnard's star has the largest proper motion of any known star at 10.39 seconds of arc annually. It also has a visual magnitude of 9.5, meaning it's too dim to be seen with the naked eye, and even despite its close distance, its intrinsic luminosity is only 1/2600th of that of the Sun's. Because of its high velocity of approach of about 68 miles or 110 kilometers per second, Barnard's star is gradually coming near to our solar system. It is estimated that it will take around 9,700 years for the star to reach its closest point to us in distance at about 3.85 light-years. But hold on for a second. How do we know exactly how far away Barnard's star is from us? I mean, after all, we're all here on Earth and Barnard's star is, well, somewhere way up there. And since we haven't quite created 36 trillion mile long measuring tapes yet, how do we measure such vast distances in space and even in the entire observable universe? In astronomy, astronomers estimate the distance of nearby objects in space, such as stars, by using a method called Trigonometric Parallax or Stellar Parallax. Simply put, they measure a star's apparent movement against the background of more distant stars as Earth revolves around the Sun. The method is based on measuring 2 angles on the included side of a triangle formed by the star, Earth on one side of its orbit, and Earth 6 months later on the other side of its orbit. It works like this. Hold out your hand, close your right eye, and place your extended thumb over a distant object. Now switch eyes so that your left is closed and your right is open. If you look closely, your thumb will appear to shift slightly against the background. Isn't that right? Yeah? Okay. By measuring this small change and knowing the distance in between your eyes, you can actually calculate the distance to your thumb. To measure the distance of a star, astronomers use a baseline of 1 astronomical unit, or AU, which is the average distance between the Earth and the Sun at about 93 million miles, or 150 million kilometers. They also measure small angles in arcseconds, which are tiny fractions of a degree on the night sky. If you divide the baseline by 1 astronomical unit by the tangent of 1 arcsecond, it comes out to about 19.2 trillion miles, or about 3.26 light-years. This unit of distance is called a parallax second or parsec, but even the closest star to the Sun, Proxima Centauri, is more than 1 parsec away. Because of this, astronomers have to measure stellar shifts by less than 1 arcsecond, which was actually impossible before recent technology to determine a distance to a star. The first known astronomical measurement using parallax is thought to have occurred in 189 BC, when a Greek astronomer, Hipparchus, used observations of a solar eclipse from 2 different locations to measure the distance to the moon. Hipparchus noted that on March 14th of that year, there was a total solar eclipse in Hellespont, Turkey, while at the same time further south in Alexandria, Egypt, the moon covered only 4/5 of the sun. Knowing the baseline distance between Hellespont and Alexandria at about 9 degrees latitude or around 600 miles, and along the angular displacement of the edge of the moon against the sun at about 1/10 of a degree, he calculated the distance to the moon to be about 350,000 miles or 563,300 kilometers, which was nearly 50% too far. His mistake was in assuming that the moon was directly overhead, thus miscalculating the angle difference between Hellespont and Alexandria. The first person to succeed at measuring a distance to a star using parallax was F.W. Bessel, who in 1838 measured the parallax angle of 61 Cygni as 0.28 arcseconds. This gives a distance of 3.57 parsecs or 11.644 light-years. By measuring the distance to many nearby stars, astronomers have been able to establish relationships between a star's color and its intrinsic brightness. These stars can then become standard candles. If a star is too far away to measure its distance using parallax, astronomers can match its color and spectrum to one of the standard candles and determine its intrinsic brightness. And once again, please consider subscribing, and thanks for watching.